Introduction to Advanced Higher Differentiation 1. Our first lesson shall not be assessed in the course, so you don't have to worry about that. However, we shall introduce you to proven results, which is part of the course. So today we shall explore how derivatives occur and aim to understand the method of first principles. If you have a graph with a function, let's say it's just called f of x, then let's go to a point on the x-axis. Let's call it x, start there. Then what would the y-coordinate come out as? If the function is simply called f of x, then the only way to find the y-coordinate is to substitute x in, so we're going to call it f of x, okay? So let's call this point A. What if we move a small distance along, so a small change in x? Then let's call that h just now. You will find that in different textbooks and different videos and so forth, they'll use different notations. So just to let you know, the small change denoted by h can also be denoted by d, delta, or a triangle as well. So when you're looking at any videos, that means a small change. If you move along a small amount, let's say h, then you will be at x plus h in the y-axis. So what would the y-coordinate come out as? Just like you've used functions in higher, if you had f of x, then x plus h would be f of x plus h, and let's call that b. So now we can express the rate of change or the gradient using this information. What we've got here is the graph that I was using, except I put the line there so that you could imagine the tangent to the line at that point. And here, over here, I'm showing you that I'm getting closer and closer. The h is getting smaller and smaller, and this will give the gradient of the tangent as a and b get closer together. So eventually, you'll find the gradient. How do we do this? Through calculation of the coordinates. If you have the y values being f of x plus h and f of x, then the difference in the y's will be as so, and the difference in the x's, what you'll notice is the x's can cancel down there. What does that mean to us? We are trying to find out the small change in the y's over the small change in the x's. And then remember that also gradient is represented through differentiation, or differentiation represents gradient. So that means that you can say the gradient is also dy by dx, or using your fancy new notations, you might see the triangles with delta, d, or the funny delta symbol, or the triangle represents a small change. That means to find the derivative is also the same as to find the gradient, which means as h tends towards 0, we can find an expression. What's happened here? We've just collected the denominator, cancelled out the x's, and this is what's actually called first principles. When we use this, we can find a derivative, and that's what you're going to do today. So this technique is known as first principles. We look at what happens to the function as h tends towards 0, and when substituting it into this, then we will actually find the derivative. So it can be used to find the derivative of the function, the gradient, the rate of change. Normally we won't go through this whole process, but it's actually very nice for you to have an appreciation of how to use this technique and how your derivatives have actually occurred. I'm going to stop this video here now. All you need to do is have this part written down, because I'm finding it very difficult to upload lots of things as videos. I have to make them shorter, so that is your introduction to the first principles rule, and in your next video you're going to find that we are going to learn how to use it. Okay, so to upload smaller videos, I'm going to stop now. This PDF even has everything all together, so now we're going to find some derivatives in a moment.